Hey guys, welcome to day 2 of 7 of your linear function kind of unit. Today we're going to talk about what equations with two variables look like. So just a review, you have kind of just worked with equations with one variable. So typical one is x. So if you have the equation 2x plus 5 equals 7, I'm hoping at this point you know how to solve these. You would subtract 5 from each side to get 2x equals 2. Divide 2 from each side to get x equals 1. So that is the solution to the equation. Okay, there's just one solution. X can only equal 1. It's the only thing that makes it true. So we are actually going to talk about what happens when you have equations with two variables. So in this situation, solutions are actually ordered pairs. So the ordered pairs are the things that you graph. So like the x, y, x comes first, then comes y. So an example of an ordered pair would just be 2, 4. Okay, x would be 2, y would be 4. So a solution when there are two variables are going to be ordered pairs that make the equation true. So you're literally just going to be working on finding solutions in this little lesson. Not too hard, but so we're going to find the solution of y equals 3x for x equaling negative 1. So they give you the equation y equals 3x, but they tell you that x is negative 1. So remember that I said that the x was always considered the input, and then y is considered the output. That's because you usually know x and then you're looking for y. So in this case, I know what x is, so I'm going to plug it in. 3 times negative 1, so therefore y equals negative 3. So I would say that the ordered pair is, remember, the ordered pair is always xy. It would be negative 1, negative 3. That right there is the solution that makes that equation true. Okay? So just to give you a better picture, so I created this monster for you. I didn't name him yet, so I'm going to leave that up to you. Drop me a comment of a cool name for my little monster. But so I want you to kind of think of equations as like a rule that you have to follow. The input or the x always gets dropped into it. The equation is what happens to it, and then it outspits the y or the output of the equation. So x goes in, y comes out. So we're going to use the equation y equals x plus 1 to practice our input and our output. If I don't tell you the input, you kind of get to pick whatever you want. Obviously, go for easy ones. Like, don't pick 123 as your input. I always like to pick 1, 2, 3, and 4. If you want to be more adventurous, go for it, but I like to keep it simple. So in this situation, if I input 1, so if I throw 1 into my monster machine, I am putting 1 in for x. So it would be y equals 1 plus 1. So y would equal 2, and it would spit out 2. So my output would be 2. Same thing. I could say, well, no, this time I'm going to put into my machine 2. It goes through the machine. It tackles the equation y equals x plus 1. So y is going to be 2 plus 1. Y is 3, so it spits out 3. Okay, it's like a rule it has to follow. So I'm sure you can figure out if I input 3, it's going to spit it out to be 4. If I input 4, it's going to spit it out to be 5. So I just came up with a bunch of ordered pairs that are solutions to this equation. 1, 2 is a solution. 2, 3 is a solution. 3, 4 is a solution, and 4, 5 All of those are solutions to the equations. Notice there's many different solutions, and I'm going to talk about that a little bit later, but there's an infinite amount. You could put whatever input you want in and get an output. So these equations, many solutions, unlike what you are used to from the past, because there was only one, okay? So in this lesson, we're just going to talk about, I'm going to give you the input or the X, and you have to find the output or the Y. Not too shabby. So we have the equation Y equals 2X plus 1, and they tell us that X equals -3. So we're going to take -3 and put it into our equation. Y equals 2 times -3 plus 1. Simplify, 2 times -3, -6 plus 1. Oh, don't forget your integer rules. I have -6, I add a 1, so Y equals -5. But you're not done. Don't forget, you have to put it into the ordered pair. So don't forget, it's XY. So it would be -3, -5. And that is your solution when X is -3. Okay. So if you feel confident enough, I want you to pause the video. You're going to find the solution to both of these when X equals -3. If you don't feel confident enough and you just want to watch me do it, go for it, but be a little adventurous. Try some on your own, okay? So pause it if you want. Okay. So I know that X is -3. I want to find the solution if X is -3. So -4 times -3 plus 3. -4 times -3 is a positive 12. 12, oh, why did that just make it B? Oh, that's weird. Okay, so plus 3. So Y equals 15. So the solution to this equation when X is -3 would be -3, 15. Same thing for this one. If X is -3, Y equals 0 times -3 minus 4. 0 times -3 is 0. 0 minus 4 is -4. So the solution would be -3. -4, okay? Just throwing a word problem at you because why not? So the equation, T equals 21 minus 0.01 N, models the normal July temperatures in degrees Celsius out at Mount Rushmore, South Dakota. In the equation, T is the temperature at N meters above the base of the mountain. So this equation is just the relationship between the temperature and where you are compared to the base of the mountain, or how many meters you are from the base of the mountain. So we're going to find the normal low July temperature at 100 meters above the base. So it's above, so it's going to be positive. So the temperature would be 21 minus 0.01 times 100. I can simplify that. So 21 minus, that would be 1 because I moved the decimal twice. And then 21 minus 1 is 20. So at 100 meters above the base, it would be 20 degrees. Okay. So just to kind of show you where we're headed with this, all of these equations or functions that we're dealing with, they're linear, so they're going to create lines when we graph them. But these relationships have many solutions, just like I showed you with my monster. Many solutions. But that's why we graph things, because the graph actually represents all of the solutions. So there's actually this really cool website you can go to graph functions. I may show it to you if we have time, but I actually went and I graphed the equation that was in this problem, T equals 21 minus 0.01 N. So this red line that you see right there, that's actually the graph that represents that equation. So that line is every single solution that this equation represents. So if we kind of go to check ourselves, we wanted to find 100 meters. So 100 meters is considered our input, and our input is going to be the x-axis down here. So this is meters down here. So if we would go and find 100 meters, well, here's 200, so 100 is going to be right here, and follow it up to the graph. Where does it hit? 20 degrees. So this graph is actually every single solution to that equation. And that's why graphs are so neat, because it's kind of telling you all of the answers. If I'm blowing your mind right now, I apologize. We'll get there. But if you want to figure out if you are 200 meters above the base, you would follow it up to the line. It's going to be 19 degrees at 200 meters. And you can keep following it down. At 600 meters above the base, using the graph, you're going to know it's 15 degrees. Okay, so that's actually how you use graphs, and that's where we're going with all of this. So nice little preview. So just to show you what you're going to be doing on the formative that you're doing today, I made it multiple choice to try to make it easy for you. But so what you're doing is trying to pick which ordered pair is the solution. So I give you the equation, and you have to figure out which ordered pair out of these three is going to be the solution. So you know that it's x, y. So just take your x and plug it in. So if I have y equals 3x minus 5, plug 4 in for x. So y equals 3 times 4 minus 5. Y equals 12 minus 5. Don't know why I put that parenthesis behind that. Losing my mind. So then y equals 7. But it has 12 here, so that's not the solution. So then try the next one. So if x would be 2. So y equals 3 times 2 minus 5. Y equals 6 minus 5. Y equals 1. 6 minus 5. Woo, yeah! If I put 2 in for x, I do get the output, or y, 1. You should check the third one just to be safe. I'm not going to do it for time's sake. Same thing for this one over here. So if I have the equation y equals negative 3x plus 2, I want to figure out which of these is going to be the actual solution. Start by plugging in all of your x values. So y equals negative 3 times 5 plus 2. Negative 15 plus 2. Y equals negative 13. Nope, can't be that one because they said it's negative 10. So y equals negative 3 times 3 plus 2. Y equals negative 9 plus 2. That would be negative 7. Oh boy, hope it's the last one. So y equals negative 3 times 2 plus 2. Y equals negative 6 plus 2. And good thing, negative 6 plus 2 is negative 4. So that right there is the solution to this equation, okay? That's what you're going to be doing on the formative. If you have questions, please do not hesitate to reach out. I know this is weird and new, and I'm throwing a lot of crazy stuff at you, but please email me if you're having trouble.